Hi everybody, welcome to Unit 3, Lesson 11, Multiply and Divide Rational Numbers. So we've been working on this throughout the entire unit, and now we're going to kind of put it all together, okay? And after this, it's your unit review and test, so hopefully you'll feel prepared. First off, if you remember from our work with addition, we have the associative property and the commutative property. So both of those properties work for addition and multiplication. So right here I have two examples, one for the associative property, which tells me that even if I move those parentheses and I multiply in what would then create a different order, right? Like in this case I would multiply B and C together first and then multiply that by A. That is the exact same thing as me multiplying A and B together first and then multiplying by C. So again, furthering the structure and the understanding of that the order in multiplication and addition don't matter, okay? You're still going to end up down to the same answer as long as you're doing your operations correctly. The same is true for the commutative property. So just like with addition, right? It doesn't matter the order that you add. 2 plus 3 equals 3 plus 2. Same thing with multiplication. A times B is the same thing as B times A. Alright? So those are helpful as we go through problems, especially when there is more than one operation going on. Okay? So, okay, hopefully that, I don't know what just happened, but hopefully that didn't impact the recording. I guess we'll find out. So I have some examples for you. The first two are from your practice, and then the final one is from your quick check. All right? So let me go ahead and try to focus that a little bit. So here I have negative 3 divided by 3/4 times 2/7 times negative 5/16 divided by 5/7. Holy moly, there's a lot going on there, right? Well, the first thing, whenever you see a problem like this, the first thing I would do is, one, we've got division and we've got multiplication. But we've got some fractions and division. And when we divide with fractions, we know that we need to, dividing by a fraction is the same thing as multiplying by the reciprocal. So if you remember from previous videos and previous lessons, that's like same, change, flip. Okay? So I'm going to do that. One, I'm going to write, hopefully that's a little better. I'm going to multiply, or I'm sorry, I'm going to turn this negative 3 into a fraction, which you can turn any integer into a fraction by putting it over 1. So I'm going to call this negative 3 over 1. And then I'm going to do this on the same level. I'm going to change my symbol, and I'm going to flip my second fraction. Okay, same, change, flip within that division. All of that is being multiplied by 2/7, which is being multiplied by negative 5/16. Oh, look at that, we've got division again, so we can do same, change, flip. I'm going to leave my first one the same. I'm going to change my symbol to multiplication, and I'm going to flip my second fraction. Now the nice thing about doing that is now they're all fractions, okay? And now what I can do, because of the commutative property of multiplication, I can rearrange these to put numbers close to each other that actually make sense. So these make sense because there's a 3 in the numerator and a 3 in the denominator, and that's a big part of what this lesson is about, is like, what can we reduce by beforehand, or what can we cancel out in order to make our lives easier, rather than multiplying all these numbers together and then ending up with a massive answer, okay? So what I'm going to do, because what I've noticed is, let's see, these two look good next to each other. I like them. And I'm going to leave this 2/7, but then, or actually, you know what, I lied. I'm going to move, let me get rid of this guy. Use my handy dandy whiteout. What I meant to do is I'm going to flip these two. Because of the commutative property, I can do that, right? So I'm going to put negative 5/16 here. And the reason why is because I notice that there's a 4 in my numerator here and 16. They have something in common, right? They can both be divided by 4. And so I like that, all right, because that will help me reduce. So if I do that, then what that means is that next I'm going to have my 2/7, and then I have my 7/5. And I like those next to each other too, because look, there's a 7 in the numerator and the 7 in the denominator. Okay? So that's really helpful. Because now what I can do, remember when you're reducing fractions or when you're simplifying fractions, right? You're looking for something in the numerator and something in the denominator that they can be reduced by, right? That they have in common. So let me switch my color here. So right here, I could divide that by 3 and divide that by 3. And I'm keeping it balanced because I'm doing 1 in the numerator, 1 in the denominator. And because I'm multiplying them together, right, eventually I would be multiplying straight across, and then I'd be able to reduce by 3 later, or I can do it now and make my life a little easier. So 3 divided by 3 is 1. 3 divided by 3 is 1. So now I can rewrite these. I could say, okay, let's see, I've still got this negative. I have negative 1 over 1 times, and I haven't touched my 4 over 1 yet. 4 over 1 times negative 5/16 times 2/7 times 7/5. Now, we don't have to rewrite it every single time. We could do multiple steps in one go, and I'm going to do that now. Okay, so let me move my document camera. I'm running out of room on my page, so hopefully this will work out okay. Like I said before, 4 can be divided by 4, so can 16. 16 can be divided by 4. And then notice here I've got a 7 in my denominator and a 7 in my numerator, so both of those could be reduced as well. So like 7 divided by 7 is 1, 7 divided by 7 is 1, 4 divided by 4 is 1, 16 divided by 4 is 4. Look at all that I reduced. Look at all those ones. I love seeing that in multiplication because just multiplying by 1 is just itself. So here I have negative 1 over 1 times 1 over 1, right? That's this guy, times negative 5 over 4 times 2 over 1 times 1 over 5. And actually, I could reduce these ones too, right? Those are both, I could have moved this one over here so that we could have seen that. I didn't even catch that until now. I could rewrite those as a 1 and a 1. And now I can multiply straight across. Look at all of those numbers. We could even do it here with the 2 and the 4. Holy moly, right? 2 can be divided by 2. 4 can be divided by 2. And so we just keep going, right? So 2 divided by 2, 4 divided by 2. Well, let's see. 2 divided by 2 is 1. 4 divided by 2 is 2. So I think that's everything. It looks very messy, so I got to make sure that I keep track of what I'm doing. First off, I have a negative times a positive, right? But then there's this other negative here. And remember, a negative times a negative gives you a positive. And in that case, that would get rid of all my negatives. So I'm only dealing with positives. And in the numerators, I've got 1 times 1 times 1 times 1 times 1. Woo! A big old 1, right? In my denominators, I have 1 times 1 times 2 times 1 times 1. Well, really that's just 1 times 2, which is 2. And again, because we got rid of our negatives, our final answer is just a half. Now, did I have to do all of that? No. But once you start understanding how numbers interact with each other, then you can do things like that. You can take those numbers out, reduce, right? All of those things before you multiply. Now, if you were totally uncomfortable with that, well, go ahead and do this whole process, right? Like from here, go ahead and multiply straight across and get the really big numbers, but then eventually you'll notice after you start simplifying after the fact, eventually you should get back down to 1/2, okay? So it's pretty amazing how we can manipulate the numbers like that to help us. Okay, number 2, how many ounces are in 1/2 of 1/5 of a 10-ounce block of cheese? Well, first off, we need to understand, so we have like, imagine like a big block of cheese. We only have 1/5 of that. So it's like if that were cut into 5 pieces, we only have one of those pieces. And then we have half of that. So we want to know how many ounces is that actually equal to. You could draw yourself a picture to help you. Another thing to understand is this word of. Let me use my other color. Of. Half of 1/5. Of 10. That word of means to multiply. So equation-wise, we could solve this problem by saying 1/2 times 1/5 times 10. And that's going to get us down to our final answer. Okay? So, with that, let's see here. First thing I'm going to do is I'm going to make my 10 into a fraction by putting it over 1. So we can have 1/2 times 1/5 times 10 over 1. Now, you might notice, and I hope you're starting to notice that, there's a number in my denominator and a number in my numerator that they have something in common. They can both be divided by 5. So if I divide that by 5, divide that by 5, well, 5 divided by 5 is 1. 10 divided by 5 is 2. So now my multiplication is a little easier. I have 1 times 1, which is 1, times 2. 1 times 2 is 2. And then I've got 2 times 1 times 1, right? Which is 1. Which is 2. Well, 2 over 2, if I have 2 out of 2 of something, 2 pieces, right? I'm just left with 1. So my final answer is that I have 1 ounce left. That's what it was asking me. How many ounces are in 1/2 of 1/5 of a 10-ounce block of cheese? Well, let me draw a picture, okay? It's probably not going to be perfect, but I will try my best. Let's just say this is our block of cheese. I'm going to break it up, and here's the real test. Can Miss Angel break this up into 10 equal pieces? Let's see. Ooh, kind of close. It's not too bad, right? Okay, here's my 10 ounces of cheese. Okay, do you agree with that? 10 ounces of cheese. Well, if I were to break that up into fifths, right? Fifths, because like I said, we have 1/2 of a fifth. Well, here's 1/5. Here's 1/5. Here's 1/5. Right? I have, and think like here's 1, 2, 3, 4, 5 equal pieces, right? But I have 1/2 of one of those. Well, if I'm only focusing on this fifth right here, right? There's my fifth I'm focusing on. I only have 1/2 of it. That's all I have. And going back to the original problem, right, asking about ounces, well, if I have one of those pieces out of 10 ounces, I have 1 ounce. All right, so hopefully that helps you see that I'm not just pulling your leg with the multiplication, okay? So that's a good, realistic, real-life example. Oops, I don't need to turn the page, I just got to move it down. Number 3, a runner completes 1/4 of a 5-mile race every 8 minutes. At the same pace, how far can the runner go in 16 minutes? Okay, well, there's a couple things going on, right? We've got 1/4 of, there's that of, so 1/4 of, remember, means to multiply, of 5 miles. So I'm going to put that over 1. I'm just going to get in the habit of making it a fraction, right? So I need to see how many miles is that, and he goes that distance in 8 minutes. Well, the key here is like, okay, if he goes that in 8 minutes, but we want to know the amount in 16 minutes, couldn't that just be doubled? Whatever this amount, we could just double it, right? Because the minutes were doubled. So first, let's see, how far does he go, or she, go in 8 minutes? That's what this is going to give me, okay? I've got nothing in common. I can't reduce beforehand, but I can multiply straight across. So 1/4 times 5/1. 1 times 5 is 5. 4 times 1 is 4, okay? Giving me 5/4 miles. We could also rewrite this as 1 1/4 mile, right? 4 goes into 5, 1 whole time. We have 1 left over until we get to 5, and our fourths still stay the same. So in 8 minutes, they went 1 1/4 mile, okay? But we want to know in 16 minutes, so 16 is doubled from 8, so we just need to double that from here. So we have, and we could even take that 5/4 times 2/1, right, which is just the same thing as doubling or multiplying by 2. Well, one thing I notice is that I have a 2 in my numerator and a 4 in my denominator. So both of those can be divided by 2. So I can reduce beforehand. So 2 divided by 2 is 1. 4 divided by 2 is 2. So I can rewrite that whole thing as 5/2 times 1/1, which is equal to 5/2. 2 goes into 5 2 whole times. 2 goes into 5 2 whole times with 1 left over out of 2. So in 16 minutes, this person can run a lot faster than Miss Angel and go 2.5 miles. Okay? I hope this helps. I know it's a lot. Reach out for help if you need it, okay?